Hi everyone. Today we are discussing about properties of continuous time systems. Properties of continuous time systems. And first topic is memory and causality. In general case, we are seeing any system or any device or any computer or any circuit which is having some memory devices or memory elements or memory blocks. Why? Because we are storing lot of information and and sharing, and then after converting signals various forms. So in that reason we have to need a particular memory device for further communications and store data for future communications. That's why any system must and should use memory devices. And causality. Causality means, for example, when we are applying input signals from input side and output side, we are getting output signals. That means the present output signals are depends on present input signals. Without input, without output. So that means when we are getting output is depends on input. At the same time, when we are also using memory device, we can see the previous records also, and we are operating process is more faster and easier compared to the other devices. That's why we are using memory and casualties. A system x and y is said to be memory. Already we are discussed a system x and y, inputs and x outputs. X and y are have memory. That means y of t depends on x of t. Already we know y of t means output signal, x of t means input signal. That means output signal will be depends on input signals. A system that does not have memory is said to be memoryless. For example, some systems or some circuits, they have not arranged and they have not used memory devices. So the type of devices or circuits are known as memoryless devices. Memoryless devices. Since its current output value cannot rely on past for future values of the input. Already in starting, already we discussed, without memory we can't use memory. So at the situation y of t not, that means output variables are not in depends on in variables. Why? Because it does not have, because it does not have any memory left. That means the current output value cannot relay past and future values. That means it memoryless devices, it displays or it will propagates present signals only, and it does not propagates and it does not use previous signals. Why? Because the systems does not have memory device. That's why it is the major drawbacks. And a system with x input and y output is said to be, fourth point, a system with x input and output y output is said to be casual. Only we know x and y are the input and outputs, so that's why these are the casual inputs and outputs. And for every real t naught of y does not depends on x of t, where t greater than t naught. And second one is, if the independent variable t represents time, If the independent variable t represents time, a system must be causal order to be physically realizable. If the independent variable t represents time, and a system must be have causal in order to physically realize. Non-causal systems have sometimes be useful in practice. However, since independent variable need not always present time. For example, in some situations, independent variable might represent positions. Next one is invertibility. Invertibility means opposite, inverse. For example, a system H is a device and another system H inverse is a combined effect of H cascaded with H inverse is a system where input and equal. That means single letters are known as casual numbers and something power of minus is equal to inverse. So this type of letters are indicates inverse or inversibility. A system is said to be invertible if it is have corresponding inverse system. A system is said to be invertibility if it is have corresponding inverse system. That means any system have performing some reverse or some opposite performance compared to the other devices or other systems, and these type of systems or signals is known as inverse signals or inverse systems. And next one is equivalently a system invertible if its input x can always be uniquely determined from its output y. Note that the invertibility of a system which involves mapping between functions, and the invertibility function which involves mapping between numbers and fundamentally different things compared to the other systems. Invertibility is performing reverse operation, and an invertible system will always produce distinct outputs from any two distinct functions. That means invertible system will always produce distinct outputs from any two distinct functions. That means it will providing output signals between distinct functions to the inverse signals. To show that a system is invertible, we simply find the inverse system. If any system have used inverse operations and invertible things, that type of systems is known as inverse systems. Next point is to show that a system is not invertible, that means positive. We found two distinct inputs and that they result in identical outputs. Last point is in practical terms, invertible systems are nice in the sense that their effects can undone. That means any system have some responsibilities, and those who are performing reverse operation is known as comparator, sorry, invertibility, and these are more differ than other systems. Next one is BIBO, bounded input, bounded output. BIBO stability, bounded input, bounded output. A system with the input x and y is BIBO stable if for every bounded x, y is bounded. That means BIBO means bounded input, bounded output. Bounded input, bounded output. That means any system have contains several inputs and several outputs. So that's why these type of stabilities are known as BIBO stabilities. BIBO stabilities. To show that a system is BIBO stable, we must show that every bounded input to a bounded output, every bounded input to every bounded output, every bounded output. Next one is in practical terms, a BIBO stable system is well balanced in the sense of that as long as the system input remains finite for all time, the output will also remains infinite to all friends. To show that a system is not BIBO stable, we only need find a single bounded input that leads to an unbounded output. That leads an unbounded output. Next one is usually a system that is not BIBO stable. We have wants to serious safety issues. Usually a system that is not BIBO. BIBO means that means they have not arranged inputs and outputs. They have not used inputs and outputs. That's why these type of devices are known as serious safety issues. Serious safety issues. Next one is TI, time invariance. Time invariance. A system H is said to be time invariant if every function x and every real t naught the following conditions hold: y of t minus 0 equal to h of x dash of t, where y equal to hx and x dash of t equal to x minus t naught. x minus t naught. Next one is a system that is not time invariant is said to be time varying. A system that is not time invariant is said to be time varying. In simple terms, a time invariant system is a system whose behavior does not change, whose does not whose behavior does not change with respect to time. In a simple term, a time invariant system is a system whose behavior does not change with persons with respect to the time. Systems speaking compared to invariant to compared time varying time orientations time orient systems are much easier to design and analyze are much easier and analyze to design since their behavior does not change since since their behavior does not change with respect to time. So at the situation we can't generate the signals. Next one is additivity, homogeneity and linearity. Additivity, homogeneity and linearity. A system H is said to be additive if for all functions x1 and x2 and x3. And next one is LTI systems. Now we are entering one of the most important topic, continuous time linear invariant. Continuous time linear time invariant. LTI system means linear time invariant. Linear time invariant. Why linear time invariant systems are used? Why we are using LTI systems? In engineering, LTI systems, linear time invariant systems, plays a very important role. Very powerful mechanical tools. Have been developed analyzing LTI systems. Have been developed for analyzing LTI systems. LTI systems are so much easier to analyze than systems that are not LTI. And in practice, systems that are not LTI will be approximated using LTI. In practice, systems they are not LTI can be well approximated using LTI models. So even when dealing with systems that not TTL and TLL still play an important role. important role. So that means the overall concept of LTI system, it is more convenient and more easier compared to the other techniques, and it will explain the behavior of society, and then after by using and also by using LTI system we can easily understanding the linear time invariant situations. So even when dealing with the systems are not a LTI or LTI systems will stay an important role. Next one is convolutions. 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 Next one is CT convolutions. CT convolutions. CT means continuous time. Continuous time. The continuous time converter of the function x and h denotes x into h is defined as the function x into h of t is equal to integration of minus infinity to infinity x of tau to h of t minus tau dt. The convolution results evaluated at the point t is a weighted average of the function where the weighting is given by the h time reversed and shorted by t. Here here we are also using different techniques. We can easily convert and we can translate the waves by using particular convolution has been LTI, has been in the context and LTI systems. That means LTI systems. In LTI system, once again I will repeat, the major working principle is and the next one is as well we see convolution is used to extensively in systems theory. In particular, convolution has a special significance in the context of LTI system. Next one is practical convolution techniques. Practical convolution techniques. To compute the convolution, the formula is x into h of t, where infinity to minus infinity. That means the integration of infinity to infinity x of tau h of t minus tau d tau is represents the compute the convolution and then we are proceed by the following functions or things or properties. First one is flat x phi of t, flat x phi of t, and h of t minus tau as a function of tau. If the condition x of tau and h of t minus tau is a function and of tau. Initially, consider an arbitrarily large negative value for t. Will this result in h of t minus tau being shifted very few to the left on the time axis. And next, third point is write the mechanical expressions for the h of x into h of t, x into h of t, x into h of t. Next one is increase t gradually until the expression for x into h of t changes form. Record the interval over which the expression for x into h of t all valid. Next, fifth point, the repeat steps 3 and 4 until t is an arbitrarily large positive value. This corresponds h of t minus tau. H of t minus tau being shifted very far to right on the time axis. The result for various intervals can be combined in order to obtain an expression x into h of t for all t's. These are the different properties and rules of LTI systems. Those who are more help to simplifying the problems to the further communications. Next one is properties of convolutions. The convolution property is commutative, that is, for any two functions x and h. Commutative means it will performing zigzag operations. For example, x into h equal to h into x. That means just we are replacing. Commutative means replacing individual terms and elements from left to right or right to left. The convolution operation is associative, that is, for any signal x, h1 and h2, x, h1 and h2. X and h1 into h2 is equal to x into h1 into h2. This is the formula for associative. Next one is the convolution operation. The convolution operation is distributive with respect to the addition. That is, for any signals x, h1 and h2. That is, any signals for x, h1 and h2. And relative formula for distributive h into x into h plus 2 is equal to x into h1 plus x into h2. X into h1 plus x into h2. And next topic is representation of signals using impulses. That means not pulses. Impulses. Representation of signals using impulses. For any function x, x of t is equal to integration of minus infinity to infinity x of tau delta of t minus tau d tau is equal to x into delta of tau. When we are simplifying integration, the final result is x into delta of t. Thus, any function can be written in terms of expressions involving delta. Thus, any function x can be written in terms of an expression involving. Moreover, delta is convolutional identity. Delta is the convolution identity. That is, for any function x into delta is equal to x. X into delta is equal to x. And next one is periodic convolution. Periodic convolution. The convolution of two periodic functions. The convolution of two periodic functions is usually not well defined. Is usually not defined. This motivates an alternative notion of convolution for periodic signals known as periodic convolution. Next one is the periodic convolution of the t periodic function x and h. X and h denoted x. X of h is defined as x star of h of t equal to integration of t x of tau h of t minus tau d tau, where integration of t denotes the integration over an interval of length t of length t. The periodic convolution linear convolution of t periodic functions x and y. The related formulas are shown below. Next one is convolution and LTI systems. Convolution and LTI systems. Next up is impulse response, IR. The speech H of a system H to the input delta is called impulse response of the system H. Impulse response of the system H equal to H of delta. That means delta will be depends on the system H, and both are depends on H, small h. The impulse response H of a system H to be input delta is called impulse response. For any LTI system with input x, output y, and pulses or pulse response H, the following relationship holds: y equal to x into h, y equal to x into h. In other words, a LTI system simply computer a convolution in other words, LTI system simply computes a convolution. Furthermore, a LTI system is completely characterized by its impulse response. That is, if the impulse response of LTI system is known, we can determine the response of the system to any input. Response of the system to any input. Since that the impulse response of LTI system is an extremely useful quantity. We often want to determine this quantity in practical settings. So, linear time invariant systems are more useful to creating signals and adjusting several signals at the same time balancing signals. And next topic is step response. The response S of a system H to the input U is called the step response of the system. For example, S equal to H of U. That means U is the step response device or element. The impulse response H and step response S of a systems are related as H of t equal to dst by dt. Therefore, impulse response of the system can be determined from its step response by differentiation. And this is the black diagram of LTI system. This is the black diagram of representation of LTI system. Often it is convenient to represent a continuous time LTI system in black diagram form. Here we are observing clearly input side we are applying x of t and output side we are receiving y of t. In the processing section we are using h of t. Such since systems are completely characterized by their impulse response, we often label systems with its impulse response. That is, we represent a system with x input and y output and impulse response h is shown in the below. For example, any signals or any LTI systems or any circuits mainly explain working principles of inputs and present outputs are depends on present inputs and systems are processing the data compressions and expansion processing to the one system to another system. And these are the different meanings and different performance characteristics of properties of signals and LTI systems. Next class we are discussing more topics. Thank you.